Hello and welcome to another video. Today we will be learning topic 1.11, equivalent representations of polynomials and rational functions. So recall this information. Let h of x be equal to f of x divided by g of x. If g of x equals 0, or your denominator is equal to 0, then h of x is going to have undefined terms when this is true at x equals c. So remember, now we have the name for the undefined terms. Your undefined terms can either be a vertical asymptote or a hole in the graph. Example number 1, let h of x be equal to x squared minus 4 over x squared plus 7x plus 10. We are going to write h of x in factor form and then find any values where h of x has a hole or a vertical asymptote. They did divide it into parts for you to make it a little bit easier. First part is asking you to do the factors for both the numerator and the denominator. So I have in the numerator, I have x squared minus 4. So I can do the difference of two perfect squares. So my factors are going to be x plus 2 and x minus 2. On the bottom one, I'm factoring out x squared plus 7x plus 10. So I need two numbers that multiply will give me 10, but added will give me 7. So in this case, it's going to be x plus 2 and x plus 5. After that, they want to know if you have a hole or a vertical asymptote. So I can see that these two can be divided out, and I don't have any x plus 2's in the bottom. So I know I have a hole at x equals -2. Don't forget I can find the y value by plugging in my x's into the factors that did not get canceled out. So in this case, I'm plugging in -2 for this x and this x as well. I'm going to do on the side -2 minus 2 over -2 plus 5. So that will simplify to -4 over +3. So that will be my y value for the hole in the graph. The other parenthesis in the denominator will give me my vertical asymptote. So x plus 5, don't forget to set it equal to 0. So then I get x equals -5 as my vertical asymptote. The domain is going to be very easy to find. I know I have two undefined terms. Or undefined values, sorry, undefined values. I know one of them is x equals -5 because that's going to be my vertical asymptote. And I know the other one is going to be x equals -2, the x value of the hole. So basically, I'm going to say that my domain can be any number except -5 and -2, since those are my only undefined values. So when I start writing my domain, I start at -infinity, and then I stop at -5. I have to exclude -5, and then go from -5 to -2, and then go from -2 all the way to infinity. So basically, I'm saying x can be any number except -5 or -2. I do like to put them in order, so when you do your domain, makes it a little bit easier. Second example. It says let k of x equals x squared minus x minus 12 over x cubed plus x minus 20x. So part A says to write the equation in factor form. So I'm going to factor out my numerator. Again, I'm looking for two numbers that multiply will give me -12, but will add up to -1. So x minus 4 and x plus 3 will be my factors. For the other ones, I know that I have the greatest common factor of x, so I'm going to pull that to the front first. So plus x minus 20. After that, I'm not done simplifying the denominator, so I'm going to keep going and factor the parentheses. So x on the front. And now I need two numbers that multiply will give me -20, but add up to +1. So in this case, it's going to be x plus 5 and x minus 4. So that's going to be the answer for part A, just the factor form. Again, we're going to see if anything divides out. So x minus 4 does divide out, so that will give me the hole in the graph. And then I know I have two vertical asymptotes because I have two parentheses remaining with x's in the denominator. And then I know I have a 0 based on my factor left in the top with what that has an x in it. So the next one says to find the zero of the function. So again, it's going to come from your numerator or your x plus 3 parentheses, set it equal to 0. I get x equals -3. For the next one, they want any x values where you have a hole. So that's the one that got canceled out. So I know that the x value is going to be 4. I like to do it as an order pair, so I'm going to plug in 4 into here. So it's going to be 4 plus 3 over 4 times 4 plus 5, which is 9. 4 plus 3 will give me 7. And then 9 times 4 will give me 36. So it will be 7 over 36 as my final answer. Next is asking me to find any vertical asymptotes. Like I said, I have 2 of them. The first one will be x equals 0 based on the first parentheses. And the second one will be x equals -5. The next one is asking me for any horizontal asymptotes. Don't forget your acronyms BOBO, BETSI, and BODI. So in this case, I'm going to be looking at the exponents. The highest exponent of the numerator is 2. The largest exponent of the denominator is 3. So I know the exponent is bigger on the bottom. So that reminds me of the BOBO acronym, bigger on bottom. And then don't forget the second O represents the number 0. It's always an equation. So my answer should be y equals 0 for my horizontal asymptote. After that, I'm going to be looking at the domain. So I'm going to write my undefined values here in order. So I have 3 undefined values, x equals 4, x equals 0, and x equals -5. So I'm going to write them in order, -5, then 0, and then +4. So I'm going to start at -infinity, skip -5, go from -5 to 0, and then from 0 to 4, and then 4 to infinity. Since this one gave me 3 different undefined values, and the number of parentheses increases. The more you have, the more parentheses you have. Again, I'm skipping -5 because that gave me a vertical asymptote. I'm skipping 0 because that gave me a vertical asymptote. And then I'm skipping x equals 4 because that was the value of the hole that I needed to skip. After that, I'm going to sketch the graph. So I'm going to start by marking the asymptote. So I have 2 vertical asymptotes, one at x equals 0, and then the other one at x equals -5. I know I have a 0 at 4. And then I also know I have a horizontal asymptote. So the horizontal asymptote will only happen on the endpoints. So I can cross through the middle part of my graph anywhere here, but I cannot cross on the endpoints or as you approach -infinity and +infinity. After that, I'm going to switch my color to another color that I'm actually using to draw the graph. And I know it will cross at -3. If you draw your graph on your calculator to help you get the shape, I know that this part will look like that. Then I know that this part will increase without bound, and now that this part is going to decrease without bound. And then I know that that side will look like that. And then I do have to add the 0 by hand. So I'm going to do that at x equals 4. And then I'm just going to add the whole. So my graph should look something like that. Okay, let's go to the next example. So on this one, you are working backwards. They want you to write the equation based on the graph. So I'm going to make a few notes about the graph to help me out. So I know I have a hole at x equals 4. And then I know I have a 0 at x equals 3. And then I know I have a vertical asymptote at x equals 2. So I want to use that to help me figure out where the parentheses go, whether they go in the numerator, denominator, or both. So if I have a hole, that will be part of both. If I have a 0, I know that's only the numerator. And then I have a vertical asymptote, I know that's only my denominator. And then don't forget, when I solve them, it has to be equal to 4, it has to be equal to 3, and it has to be equal to 2. So again, I'm kind of working backwards. So since when I solve it, I want to have an x equals 4, my actual parenthesis is going to be x minus 4. Again, I want it in both numerator and the denominator. So I'm going to do that. So that's good. Same thing for the 0. I only want it in my numerator. But again, when I solve it, it has to give me positive 3. So it's going to be kind of the opposite, x minus 3. Same thing for the vertical asymptote for the denominator. So it's just going to be x minus 2. After that, I notice that I also have a horizontal asymptote at y equals -1. If I were to say that this is my final answer, this will give me x squared at the top and x squared at the bottom. I know that these two are the same, so I will have to divide them. So my coefficient will be 1/1, which will be 1. I don't want 1, I want a -1. So how can I make this negative? By adding a negative to the numerator into my equation. So I'm just gonna erase this real quickly. So f of x equals, again, negative in the numerator or the denominator, it doesn't really matter, or you can just put it in the front. Okay, for the next example, I know I have a hole at x equals 2. I know I have two vertical asymptotes, one at x equals 0, you can see it right here, and then the other one at x equals 3. I also know I have a 0 or an x-intercept at x equals 1. So I'm going to do the same thing as before. I know that this is going to be part of both. I know that this is my denominator. And I know that this is going to be my numerator. And then I also have a horizontal asymptote at y equals 0. I can see it at the endpoints right here and right here. So let's start putting it all together. I know that g of x is going to be equal to x minus 2 at the top and the bottom. Because again, when I solve it, I want to have x equals 2. I know one of them will have an x by itself in the denominator, and the other one is going to be x minus 3. And then for my 0, again, only numerator, opposite, so it's going to be x minus 1. So when I do this, if I were to look for the horizontal asymptote, this will give me x squared as my leading term, and then this will give me x cubed. Again, it's bigger at the bottom, so I know that my horizontal asymptote is 0, so it meets all the requirements already. I don't have to change anything for that one. Okay, for the next section, it says recall, given the rational function, if the degree of the numerator is 1 greater than the degree of the denominator, then the rational function has a slant asymptote. So here we can see a graph that has the slant asymptote that I'm highlighting on right here for you. There's a few things that are happening in the graph. Vertical asymptote, which we already know how to identify. And then you also have a 0 on the graph. Keep in mind, you can now have a slant or oblique asymptote and a horizontal asymptote at the same time. So here they give us some information about the function. They give us the equation. Again, we can see the factors here. So this is where the hole in the graph is coming from. This is where your vertical asymptote is coming from, highlighted in green. And then here I have two zeros, one here at the origin, and then another one here at -2. Again, you can see them here in your parentheses, whether you're doing that algebraically or if you're looking at the graph, you get the same answer. To find the slant asymptote, you have to use long division. So we're going to go over how to do long division using numbers first to kind of help you remember how to do it, and then we'll do it with polynomials. So the old method, we're dividing 676 divided by 21. So what I'm going to do is I'm going to start dividing this number by 21, and I do get 0, so you can either write 0 at the top or you can keep going. So 67 divided by 21 will give me 3. And then you can do 3 times 21, which is 63. And then you can subtract 67 minus 63, which will give me 4. bring down the 6, I get 46. And then you repeat the steps, 46 divided by 21, which will give me 2. 2 times 21, which will give me 42. And then we're going to subtract 46 minus 42 will give me 4. And I'm going to stop there because I want the remainder. So when I write my answer, my quotient or my answer is going to be 32. And then the remainder is going to be 4. So when I put it together, it's going to be 32 plus 4 over 21. So we are going to do a similar process when we're doing a polynomial long division. So I'm going to start by writing what goes inside, which is going to be 6x squared plus 7x plus 6 divided by 2x plus 1. Same thing as before. I'm going to take the first term and divide by the first term. You can start by doing it on the side if it makes it easier for you. And then as you get comfortable, you'll start doing it without doing this. 6 divided by 2 will give me 3. X squared divided by x will give me x. Or if you remember from algebra 2, you can subtract the exponents. So 2 minus 1 will give me 1. So I'm going to write my answer here, 3 to the x. As I do this, I'm going to start multiplying. I like to do it from right to left so I don't forget and then keep it going and then get the wrong answer. So when I do it, I'm multiplying 3x by 1, which will give me positive 3x. I'm not going to put a positive because I'm going to change the sign to make it a little bit easier, especially when you get the double negatives. It kind of makes it confusing. I'm going to do the same thing, 3x times 2x, which will give me 6x squared. And then I'm going to change all the signs. So all the positives will become negatives, all the negatives will become positive. So this is positive, becomes negative, and negative. My goal is for these two to get canceled out, which they do. Then I keep on going, 7x minus 3x, which will give me 4x, bring down the plus 6. And then I'm going to try to divide again, 2x divided by 4x divided by 2x. So when I do that, I get my answer to be just 2 positive, so I'm going to put plus 2. When I do this, 2 times 1 will give me 2, and then 2 times 2x will give me 4x. Change both of their signs, so they're both positive, they both become negative, so this goes away, and I have a remainder of 4. When I do this, this is going to be my quotient, same as before, my answer, and then this is going to be my remainder. Putting it together, it's just going to be 3x plus 2 plus 4 over 2x plus 1. When you are looking for the oblique asymptote for the function, all you have to do is say y equals the quotient. So in this case, it's just y equals 3x plus 2. That is my oblique asymptote, also known as slant asymptote. So again, we use long division to find the oblique or the slant asymptote. But we can use a remainder to check if our answer is correct or incorrect on our calculator. Okay, let's look at another example. Example number 6 says let h of x equals 6x squared plus x plus 5 divided by 2x plus 1. Use long division to find the equation of the slant asymptote of h of x. So I'm going to do the same thing as before, 6x squared plus x plus 5 divided by 2x plus 1. So I'm dividing the first by the first, so 6x squared divided by 2x, which will give me 3x as my answer. After that, I'm going to multiply. So I'll multiply 3 times 1, which will give me 3x, and then 3 times 2x, which will give me 6x squared. Change the signs, so this goes away. I'm left with negative 2x plus 5. Divide again, negative 2x divided by 2x, which will give me negative 1. Negative 1 will go at the top. Negative 1 times 1 will give me negative 1, and the negative 1 times 2x will give me negative 2x. Change both of their signs, and then I get my remainder of 6. Again, I'm looking for the oblique asymptote or slant asymptote. So it will always be y equals the quotient, which in this case is 3x minus 1. And then that will be my final answer. Example number 7, they're giving you the equation for g of x. They're asking you to find the equations of any asymptotes for the graphs of g of x. The first one is just asking for the factors, so I'm just gonna write the factors very quickly. I've already found them, which is gonna be x times x minus 2 times x plus 6. For the denominator, it's gonna be x plus 1 times x plus 6, just to make this quicker. I have a hole right here on the graph, and then all they want is the vertical asymptote, the horizontal asymptote, and the slant asymptote. Vertical asymptotes again come from the bottom, so I'm going to have 1 at x equals -1. When I look at my degrees for my numerator and my denominator, I notice the degree on the numerator is higher, so I know I don't have a horizontal asymptote, so I'm just going to put none. And then for my slant asymptote, I do have to do long division. So x cubed plus 4x squared minus 12x. I'm just going to put a plus 0 here to help me out and be a placeholder. And then I'm dividing by x squared plus 7x plus 6. So when I do this, I'm dividing x cubed by x squared, which will give me x. And then I'm going to multiply x times 6, which will give me 6x. X times 7x, which will give me 7x squared. And then x times x squared, which will give me x cubed. Change all the signs, they're all positive, so they all become negative. So when I get here, 4x squared minus 7x squared, which will give me negative 3x squared, minus 12x minus 6x, which will give me negative 18x plus 0. And then I will continue. And I'm gonna divide negative 3x squared divided by x squared, which will give me negative 3. So negative 3 times 6 will give me negative 18. Negative 3 times 7x will give me negative 21x. And then negative 3 times x squared will give me negative 3x squared. Change all their signs. They'll all become positive. So then this will give me 3x plus 18 as my remainder. So my slant asymptote will be y equals x minus 3. And then I'm done. For the next one, they want to know which of the following about the graph d of x is correct. So again, d of x is equal to 2x times x plus 4 times x minus 1. I do have to factor the denominator. So when I factor this out, again, I want two numbers that multiply will give me positive 1, but add up to negative 2. So that's going to be x minus 1 times x minus 1. So again, it looks like I have a hole, but I actually don't have a hole because this is a vertical asymptote. So I'm going to make a note that I have a vertical asymptote at x equals 1. And then looking at the degree of my numerator, I know my leading term will be 2x cubed. And then for the denominator, I can see it already that it's going to be x squared. So I know I have no horizontal asymptote, but I know I have an oblique or slant asymptote because the numerator is bigger by 1. So looking at my answer choices, A, I can cancel out because it says it has a horizontal asymptote. Same for B. And then C says I have a slant asymptote, one hole, and a vertical asymptote. Again, since the x value for the hole and the vertical asymptote are the same, I actually don't have a hole in the graph. So my final answer should be D, because again, I have one slant asymptote because of the degree. I have no holes because the x equals 1 is a vertical asymptote. I can't have a vertical asymptote and a hole in the same place. And then again, I have one vertical asymptote. For the next one, they want you to sketch a graph of the rational function f of x with the following property. So I want the limit as x approaches infinity of f of x to be negative f of x. So I know the right side is going to go down. When I look at the second one, the limit as x approaches negative infinity of f of x is positive, so I want the left side to go up. So I'm just going to make a few notes. And then I want the limit as x approaches -1 from the left to be negative infinity. So I know I have an asymptote at -1, and then I want it to go down, and then same thing for this one. So when I start drawing my actual graph, again, I want the left side to go up, but then when I approach the asymptote, I want to go down. Same thing on the other one. On the other side, I want to go down on both sides, the left and the right. So my graph will look something similar to that. Again, answers will vary depending on how you draw your graph, but having the notes will help you out. Next, we will talk about Pascal's triangle and the binomial theorem. So basically, you can use this to expand or multiply binomials by each other. So you can do this very easily. On the first one, they want you to multiply x plus 3 squared. So you're going to multiply x plus 3 times x plus 3. So you can use FOIL or you can do the box. So I'm just going to do FOIL very quickly. X times x will give me x squared. 3 times x will give me 3x. And then the same thing again. So 3x and then 3 times 3 will give me 9. So when I do this, I get x squared plus 6x plus 9. If I want to do x plus 3 cubed, I can do x plus 3 times x plus 3 quantity squared, which I already have from the previous problem. Then I can do x plus 3 times x squared plus 6x plus 9, and then I can use the distributive property to do it. So I'm going to do x times x squared, which will give me x cubed, x times 6x, which will give me 6x squared, and then x times 9, which will give me 9x. Same thing for the 3's, 3x squared. Next one, 18x, and then the next one, 27. So I'm going to combine like terms. I only have 1x cubed, but I have 9x squared, and then I have 27x, and then I have 27. So as you can see, the larger this number is, or your degree, the more work you have to do. So if we wanted to expand x plus 3 to the 7, it will be a lot of work, very time consuming, and it will be very easy to make a mistake. And if you make a mistake, you will continue working with that mistake throughout the whole thing, making it very hard to keep track of where the mistakes are. So we're going to be using the binomial expansion theorem to help us do that. So this is the binomial expansion theorem equation that we're going to be working with. I will talk about the pattern with examples because it does make it a little bit easier to see the pattern when you're expanded all the way. We are going to be using Pascal's triangle. You should remember how to do combinations back from geometry, but you don't have to do combinations if you remember the pattern for Pascal's triangle. So we'll practice a little bit how to use Pascal's triangle before we get into the binomial expansion theorem. So n is going to be the number of items that you're working with, and then this is how many you're choosing to group them together. So for example, if I have 3 people like Juan, Maria, and John, and I want to make groups. So if I have 3 people and I want to make them, and I want to make groups of 0, I have one option, pick nobody. If I have those same 3 people and I want to make them into groups of 1, I can pick Juan as the one group member, I can pick Maria, or I can pick John. So that will give me 3 options. If I have 3 people and I want to group them in groups of 2, I can do these 2 together, Juan and Maria. I can do Juan and John, or I can do Maria and John. So that will still give me 3 options. And if I have 3 people and I want to group them in groups of 3, I have one option to pick Juan, Maria, and John to be in a group. As you notice, these numbers look very familiar. 1, 3, 3, 1, which when we look at row 3, those are the numbers that are given to you by Pascal's triangle. So when you're looking at Pascal's triangle, you always start with row 0, which just has one number, which is 1. Row 1 has 2 numbers. Row 2 has 3 numbers. Row 4 has 4 numbers. And then looking at this, so for row 3, since that's the one that we're looking at for the example, this is going to be 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. So these are the numbers that I did based on the combinations with the example. So keep in mind that again, you're starting with row 0, and then after that you keep on going. So you can actually find any combination. So I'm just going to keep on going. Row 4, row 5, row 6, and row 7. So for example, let's say I want to find 7, choose 5. So again, I'm going to be looking at row 7, and then this will give me 7, choose 0, 7, choose 1, 7, choose 2, 7, choose 3, 7, choose 4, and 7, choose 5. So when I do it, 7, choose 5 is equal to 21. Let's do one more. 7, choose, let's do another row actually. 4, choose 2. So again, I'm going to go into row 4, 4 choose 0, 4 choose 1, 4 choose 2. So that will be equal to 6. One more, 6 choose 4. So again, row 6, 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4. So that will be 15. This will become important when you're looking for uh, things or for terms later on in the lesson. So please make sure that you remember you always start at 0 and then you go by ones. Okay, this is what this was talking about. So now let's look at the full expansion because I'm going to point out a few things as I write the full expansion so that way you can see the pattern in the binomial theorem, and then that will help you get the correct answers when we're using shortcuts. So here, looking at my binomial theorem, is telling me that I have to start with a plus b to the n. So the left side of the binomial will be a, the right side will be b, and then the exponent will always be n. If you look here, you're always starting with n on top of the parentheses, and then at the bottom starts with 0, 1, 2, and then it keeps going all the way until you get to n. Once these two numbers are the same, you stop. For your a's, you start at a to the power of n, and then you keep subtracting by 1 until you get to a to the 0. I know that I didn't put it there, but that's how it works. B's is going to be the opposite. You start with b to the 0, and then b to the 1, b to the 2, all the way until you get to b to the end. So I'm going to be expanding the other one using the pattern, and then we'll look at some specific things once I'm done. So again, I'm going to start with a equals x, b equals 2, and n equals 5. So again, n choose 0. In this case, n is 5. And then my a is x to the power of 5. And then b to the power of 0. Plus 5 choose 1. X decreases from 5 to 4. And then 2 increases from 0 to 1. Plus 5 choose 2. X to the third, because it decreases by 1. And then b increases by 1. Plus 5 choose 3. X to the 2. And then 2 to the 3, again increasing. 5 choose 4. X to the 1. And then b to the 4. And then the last one is going to be 5, choose 5, x to the 0, b to the 5. So I'm going to point out a few things. So again, if I just look at the parentheses with the 5 and the number under it, so they go in order: 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, and 5, choose 5. If I look at my a's with my exponents, a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, a to the 0. If I look at my b's, it's going to be the opposite: b to the 0, b to the 1, b to the 2, b to the 3, b to the 4, and b to the 5. After that, I'm going to use the Pascal's triangle to get the numbers for the parentheses first. So again, I'm looking at row 5, and these are going to be the numbers in order as I write them. So the first one is going to be 1, 5, 10, 10, 5, 1. So I'm going to go back and I'm going to write those numbers. So again, it was 1, 5, 5. No, sorry. 1, 5, 10, 10, 5, and 1. So I repeat, these numbers came from my row 5. They do go in order. Again, 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, and 5, choose 5. When you look at your expansion, you should always start with a 1 and end with a 1, and then the pattern follows inward. So the second and second to last are the same number, third and third to last are the same number. After that, I'm just going to simplify my a's and my b's. So x to the 5th will simplify to x to the 5th. 2 to the 0 will be 1. Any variable or number to the power of 0 will always be 1. Same thing for this one. X to the 4th, 2 to the 1 is just 2. Same thing for this one. It'll be x cubed, and then 2 squared, which is 4, plus x squared, and then 2 cubed, which will give me 8. X to the 1 is x. 2 to the 4 is 16. And then same thing for the last one. Anything to the 0 power is 1. And then 2 to the 5th, which will give me 32. After that, I'm just going to simplify and multiply all of these together. So 1 times x to the 5th times 1 will just give me x to the 5th. Same thing when I multiply these two: 5 times x to the 4th times 2, which will give me 10x to the 4th, plus the next one, 10 times 4 times x cubed, which will give me 40x cubed. For the next one, 10 times x squared times 8, which will give me 80x squared. And then for the next one, 5 times 16x, which is 80x. And then for the last one, 1 times 1 times 32, which will give me 32. So that will be my full expansion for this example. I am going to do the same thing for example number 11. So I'm going to write what my a is, what my b is, and what my n is. So a will be equal to 2x this time. B is going to be -1, and then n is going to be equal to 4. So this one should be easier to draw the pattern. So 4 choose 0. Again, a to the 4th, and then b to the 0, plus 4 choose 1, 2x to the 3rd, and then b to the 1, plus 4 choose 2, 2x to the 2, and then b to the 2, plus 4 choose 3, 2x to the 1, -1 to the 3, and then 4 choose 4, 2x to the 0, -1 to the 4th. There is one more thing that I wanted to talk about. If you look at your exponents, they will always add up to n. because the one is increasing by one is decreasing by one. So in here, 4 plus 0 will be 4, 3 plus 1 will be 4, 2 plus 2 will be 4, 1 plus 3 will be 4, and then 0 plus 4 will be 4. That will always happen no matter what your n is. Your exponents should always add up to n. Also, if you look at the number under the 4 for this one and the exponent for b, these two are 0, these two are 1, 2, 3, and 4. So these two numbers will always be the same no matter what. Okay, so now I'm ready to simplify. Again, I'm going to get these numbers from my Pascal's triangle from the fourth row. So looking at the fourth row, 1, 4, 6, 4, 1. So again, 1, 4, 6, 4, and 1. And then I'm going to start simplifying. So when I do this, I am multiplying 2 to the fourth power, which will give me 16. And then I am going to do x to the fourth power, which will give me x to the fourth. And then again, anything to the 0 power will give me 1. For the second one, I'm going to do 2 cubed, which is going to be 8. And then again, x cubed. -1 to the 1 power will give me -1. Plus 2 squared, which will give me 4. And then x squared, -1 times -1 will give me +1. And then for the next one, 2 to the 1, which is 2, x to the 1, which is x, and then -1 cubed, which is -1. For the last one, anything to the 0 power again is 1, and then -1 to the fourth power, since it's an even, will make it into a +1. So now I get to multiply all of these together. 1 times 16 times 1 times x to the fourth, which will give me 16x to the fourth. For the next one, I'm multiplying 8 times 4 times -1 times x cubed. When I multiply all of that together, that will give me -2x cubed. For the next one, 6 times 4 times x squared, which will give me 24x squared. And then for the next one, 4 times 2 times x times -1, which will give me -8x. And then for the last one, 1 times 1 times 1, which is just 1. And then that will be my final answer. Example number 12, instead of asking me to do the whole expansion, I'm just focusing on what I need, which is the coefficient for x to the fourth. So if you look at the pattern, all of them are going to have an n at the top, which in this case is going to be 6. They're all going to have a number here from 0 all the way through 6. I don't know what that number is yet. I will figure it out. And then all of them are going to have an a, which in this case is going to be x to some power, and then b, which is 5 to some power. I know that's going to be true for all of them. You can pause the video and look at the pattern at the top and notice how that will be true for every single term on my sequence. The one that I care about is the one that will give me x to the fourth, so that will come from my a. The only term that will make this whole thing be x to the fourth is going to be by having a power of 4 here. Like I said, your exponents have to add up to n. So if this is 4, this one has to be 2, because 4 plus 2 will give me the 6 that I want. And then, like I said earlier, this number has to be the same as this number. So I know that this is also has to be 2. After that, all I have to do is go to my Pascal's triangle, row 6, and then find 6, choose 2. So 6, choose 0, 6, choose 1, 6, choose 2. So I know that 6, choose 2 is equal to 15. After that, this will just give me x to the fourth, and then 5 squared will give me 25. After that, I just have to multiply 15 times x to the fourth times 25, which will give me 375 x to the fourth. So this is technically my answer, since they just wanted the coefficient. Another way that they can ask you this problem is to find the third term. So if I put a 0 here, that will give me the first term. If I put a 1 here, it will give me the second one. If I put a 2, which is what I have, that will give me the third. After that, I know that this is 2. Again, these two have to be the same, so I know that this is 2. And then I can find this one by doing n minus 2, which will give me the 4. So that's another way that they can ask you this same problem. If they ask to find the third term, your setup will be exactly like this one, and then your answer will be 375x to the fourth, since you have that in your homework as well. Example 13 is asking you for the coefficient of the term containing x cubed when the expression x minus 3 to the 8th is expanded. So again, I'm going to start with the things that will be the same. So 8 there, number here, a, which is x to a power, and then b, which is negative 3 to a power. So again, I know that the only number that will make x cubed at the end is to put a 3 there. And then this one has to be a 5 because I know that these two numbers have to add up to 8. After that, I know that this number and this number have to be the same, so I know that this is 5. So you can use your Pascal triangle to figure out what 8 choose 5 is. On your paper, you might have to draw your own and expand all the way to row 8, because we only did all the way to row 7. So to do it, start with a 1, end with a 1, and then add the numbers in the middle to get your Pascal's triangle. So you can do that. I already know that this is going to be 56, so double check that on your Pascal's triangle, and then this is going to be x cubed. And then I'm going to do negative 3 to the power of 5, which will give me negative 243. And then after that, I'm going to multiply those two numbers together, which will give me negative 13,608 x cubed. And then this will be my answer. Again, another way that they can ask you, it will be to find the fourth term. If they do ask you for that, this will be your answer. Thank you for watching this video. I know this one was pretty long, but hopefully you learned something. Don't forget to like the video and subscribe. Thank you for watching. Have a great day. See you next time.